All right, today we're going to talk about writing equations from tables and graphs. So hopefully you watched the video last night for homework and you know the difference between an additive and a multiplicative table. So what we're going to do is we're going to talk through some tables and graphs and how to create an equation from those tables and graphs today. So the first thing that we need to discuss is we need to discuss time. So time is always independent. Okay, independent. So remember, we learned that independent means the x-axis. Okay, we learned that last week. Independent means the x-axis. And time is always going to be independent. So when I say time, what am I talking about? What are some examples of time? Well, we could talk about days. We could talk about months or weeks or years. Okay, time could also be minutes, hours, or seconds. Okay, so those are all examples of time. So if it's talking about any of these things, all of these are time and they have to be independent. They have to be on the x-axis, okay? So we have three different kind of visuals that we're going to see in this unit. So we have a table that runs horizontally, so side to side, and you can see that we have our x values on top and our y values on bottom. Okay, so our x values on top, those are going to be our independent values. Again, we learned that last week. And our y values are going to be our dependent values. Okay, so y is our dependent values. And then we have our vertical table, which runs up and down. And we can see that the first column is hours. And we know that that first column represents our x. And then money earned represents our y. So if you see a table and it doesn't have the labels, x is going to be on top and y is going to be on bottom. And then if it's side by side, x will be first and then y will be second. Okay, so those are the kind of different two kinds of tables. And then we also have a graph. So remember our corner here is 0, 0, and that's called the origin. And remember this axis over here is your x-axis. And again, that has to be our independent axis. And you can see time is located right there on our independent axis. And then we have y up here, and y is going to be our distance in miles. And so that's our dependent axis. Okay? So remember, time has got to be x. If for some reason time is not x, right? Hours worked would be x. Then if time is not x, that's a wrong answer. Wrong answer. That's an easy Joe Schmo if time is not x. Okay? So if the graph of a line goes through the origin, so just like we talked about up here, the origin, right? 0, 0, it will have an equation with multiplication, right? Multiplication or division. Okay, so if you see if you see a graph like this and it goes through 0, 0, then we know our equation will either be multiplication or division. It will not be adding or subtracting. Okay, and then we have these vocabulary words here on the front. If you want to check those out, these are just some words that mean to add, subtract, multiply, divide, and then some equals words. All right, so let's open it up and talk through a few examples. All right, our first example says, which equation represents the relationship in the table? Ms. Talamontes gave extra credit on the last test to all students who came prepared to class that day and brought a can for the canned food drive. The table shows the total points based on the student's test score. Which equation could be used to find P, the total points depending on the student's test score, S? So we have test score, which is S, and it's also our X value. And total points, they said, is going to be abbreviated as a P. P for points, S for score. Okay, and the reason that I fill those in is you can see each answer choice has a P or an S. And so I want to make sure that I use the right number to go with the S's and the right number to go with the P's. All right. So yesterday we learned to look at the table and try to see the relationship. So how did I get from 91 to 95? Well, that relationship was +4. And you can see that relationship is true all the way down. 86 plus 4 is 90, 85 plus 4 is 89, 80 plus 4 is 84. So this is an additive relationship. Again, that was our notes yesterday, and they were given as homework. You were supposed to watch that Edpuzzle. So again, this is an additive relationship. We know the relationship is plus 4. All right. And so now that we know that relationship and we have an equation, right? We have 4 different equations. We are just going to plug in. So we're going to give the numbers, we're going to take the numbers that they gave us, and we're going to plug in to prove our answer, to show our mathematical proof, okay? So I know that this is not a multiplicative relationship, right? So this is multiplying for us. So that is multiplicative, okay? So we know that one's wrong. We know that this is not a subtraction. And so both of these are out because we can see our relationship is plus 4. And so our best answer is going to be D. But again, we need to mathematically prove that that is the right answer. So I'm going to take the numbers they gave me, and I'm just going to pick one. So I always pick the last piece of the table. I'm going to pick the last piece of the table, and I'm just going to plug in. So again, I'm going to relabel. This side was score, so I'm going to label that with an S. And this side was points, so I'm going to label that with a P. And so when I plug in, I'm going to plug in 80 for the letter S, and I'm going to plug in 84 for the letter P. So again, P was 84, and then equal sign S was 80 plus 4. So does that equal that? Does 84 equal 84? Yes, it does. And so because this is a true statement, then D, we have mathematically proven that D is the equation that matches this table. Again, we had equations to choose from, and so we just plugged in to prove our answer. We just plugged in. And that was example 1. All right, let's skip to example 2. So example 2 says the carpenter charges $720 for 18 hours of work. She charges the same amount of money for each hour of work. Which table shows the relationship between the amount of time the carpenter worked and the amount of money she charges? So again, we have time on our x-axis, time, time, time. So we can't eliminate any answers based on time because time does fall on the x value for all 4 tables. Remember that when you have tables as answers, we're going to butterfly. And so we're going to do that with these numbers here. We have $720 and 18 hours. Well, let's go ahead and eliminate our Joe Schmoes. So you can see when I zoom in here, let it get a little clearer, you can see that 720 is here, 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 and here. And none of these are the 18 hours that it matches. So this is a Joe Schmo, okay, because the 720 is there, but the 18 does not have a match there. All right, and then none of these other ones have it. This one does, but is it 18? No, it's 19. And again, that is a Joe. So these 2 are out simply because they had the number, but it did not pair up with the other number. The other number should have been 18. In this one, it matched 19. Here it matched 14, 15, 16, and 17, but not 18. So these 2 are gone. So now it's between A and C. And again, when you have tables as answer choices, you are going to butterfly. So I am going to fill in the information they gave me. Okay, so they gave me 18 and 720. And again, they gave me 18 what? 18 hours. So that's why I put it underneath the hours column. And then how much money? 720. So you can use any of these values to butterfly. It does not matter. You can choose the bottom one. You can choose the top one. It doesn't matter, but we need to use the 18 and the 720. Okay, so I'm going to use the top one just because they're smaller numbers. So I had 2 hours is $80, and again, the question said 18 hours is $720. So we have hours and we have dollars. And I'm just going to butterfly those. So 720 times 2 is 1440, 1,440. And then this side, 18 times 80 is also 1,440. So those came out equal. So A is my best table, and I have shown my mathematical proof. Okay, I don't need to solve this one, but if I did, I could just pull out whichever ones I wanted and then butterfly them with the 18 and the 720. And that's example 2. All right, let's try example 3 and we'll be all done. So example 3 says the owner of a food cart sells an average of 120 frozen treats per day during the summer. Which graph best shows the relationship between the number of days and the number of treats sold? So the first thing that I'm going to see is 120 frozen treats per day. So hopefully at this point in the year, you know that per is a multiplying word, and if it just says day, that means per one day, okay? And remember, day is time. Time is days, and so I know that days has got to be on the x-axis because time is always independent. So the first thing I'm going to look for is the days on the x-axis. So remember, this is my x-axis down here at the bottom, and I'm looking for days. Okay, so is this days? No, this is number of treats sold. So this is a Joe because time is not independent. Time is not on the x-axis. Same thing here, number of treats sold. Nope, that's a Joe. Okay, Joe Schmo answer because X is not time. Okay, it's not time. Down here you can see number of days. Yes, time is on the x-axis. Number of days, yes, time is on the x-axis. So it's between these two options. So when we see graphs, we are looking to create a table, right? So we have days, right, which is our x, and we have treats, which is our y. All right, so how many days? 1. How many treats? 120. So we could keep going and skip counting like we've learned the ratios. So counting by ones, 1, 2, 3. Counting by 120s, 120, 240, 360, right? So this is kind of the table that would go with the question up here. So now I want to see which one of these would match the points on my graph. So if I go over one day, right, like we're going on a coordinate plane, and I'm going to go up to 120. So is that right above 100? Yes. So that looks pretty good. Okay, so if I go to 2 days, is that going to be at 240? Is that kind of right in the middle of 2 and 300? Yes, that looks pretty good. So let's check our third point. 3, we go over 3, and then we're going to go up to 360, which is right in between 300 and 400. So this table looks really good. This graph looks really good to match the table. So let's check this one just to be sure. So in this one, we went over one day. Did we go up to 120 treats? No, we're actually below 100. So this point is in the wrong place, and therefore that's a wrong answer. So B is our best option. So again, I looked at my relationship. I said, oh, time is x-axis. That means I eliminated these two. I created my table with days on the left for x-axis and treats y, and then I just plotted my points to see which one matched. And that's example 3. And that's all we got to do, guys.